All right, today we're breaking down a really powerful architectural pattern, CQRS.
Well, it starts by solving a really common problem that most big applications eventually face.
Look, most applications start out this way. One server, one database. Simple, clean, effective.
But this simple approach has a hidden weakness that only shows up under heavy load.
Think about an online store. You have thousands of people just reading data, while others are trying to change it.
See, when you write data, the database locks it. This forces all those readers to wait. It's a huge bottleneck.
The solution? Stop treating all data operations the same. And that is the whole idea behind CQRS. CQRS just splits the work in two. You have commands for changing data and queries just for reading it. Okay, so this simple separation gives us two completely independent paths, each optimized for one specific job. The command side gets our write database. Its only job to be the one single source of truth. Then, the query side gets its own read database. It's a specialized copy built for pure, lightning-fast reads.
Okay, so if they're separate, how in the world does the read database ever get updated?
Simple. They use events. The write DB announces a change, and the read DB listens in and updates itself. Now, this is where things get really powerful. This separation lets us use the perfect tool for each job. So for writes, you can use a solid, structured SQL database. But for reads, a speedy NoSQL one is perfect. Of course, this incredible power isn't free. There is a fundamental trade-off you have to make.
It's something called eventual consistency. Because of that sync delay, your read data might be stale for a few moments.
So the choice is clear. You can have perfectly consistent data or a system that almost never crashes under pressure. And this pattern can be enhanced even further with something called event sourcing. Here, instead of just saving the current state of the data, you save every single change as an event. So this pattern is perfect for really complex, large-scale systems where performance and reliability are everything. So you have to ask yourself, for your app, is slightly delayed data an okay price for a system that almost never goes down?